In this video, we are going to discuss stack implementation using linked list. As we have already discussed implementation of single linked list, how we can uh, insert into the single linked list, how we can delete from the single linked list. Similarly, now we will use that linked list to implement the stack. So first we will discuss the definition, basic definition of stack, then basic stack operations, then implementation of a stack using linked list. So what is a stack? A stack is a list with the restriction that insertion and deletion operations can be performed only from one end, called TOP of the stack, and these operations are called push and pop respectively. The most recently item always added on the top of the stack. Element added last is removed first, so it is also called LIFO, last in first out, or we can say FILO, first in last out. These are some real life examples of stack: a tray of cafeteria, a stack of cafeteria trays, a stack of shoes, etc. Basic stack operations are initialize the stack, pop an element of the stack, that is also called deletion, push an item onto the stack, that is called insertion. In the stack, is the stack empty? This is another operation. Determine stack size. So we will try to discuss these all operations into this video. Implementation of the stack using linked list. The stack can be implemented by the following two ways: using arrays, but in array there is a limitation of memory. Once we have initialized the array, that cannot be exceeded at the time of execution of the program. Second thing is using linked list means we can also implement stack using linked list. We use dynamic memory allocation, in which we allocate memory dynamically. At the runtime, you can just increase or decrease the memory. Linked list definition, which we have already discussed in our previous videos. I will share the link, so by which you can go into the detail. First complete the linked list, then start the implementation of a stack using linked list. A linked list is a collection of entities that we called nodes. Here we can see this is the linked list. These are three nodes: node number 1, node number 2, node number 3. Each node contains two fields, one to store data, as we can see in the diagram. Every node is having two fields. One is to store the data, and second part to store the address of the next node, and another to store the address of the next node. So you can simply see this is the top. We are saying it is, we have discussed in the single linked list, we were calling it as a start. So this is simply a pointer variable which will hold the first node address. Now come to the basic operation or the main operation in stack: insert and delete. Now we have two options. In stack we can either insert or delete from one end. So now in linked list we have two ends, in the starting or in the end. So this is called the beginning and this is called the end. As we have already discussed in insertion and deletion in single linked list, insertion can be done in either by three ways: in the beginning, in the end, or in between two nodes. Similarly, deletion can also be performed from the beginning, from end. We should apply insertion or deletion from only one end. Then we can say this linked list is behaving as a stack. So at the end of the list, this operation takes O and time complexity. If we apply insertion and deletion from the end of the linked list, then we will say first we have to traverse all the linked list. So suppose linked list is having n element, then every traverse will take at least O of one time. So overall, if linked list is having n element, then it will take O of n time. So at the beginning of the list, if we are applying the same operations in the beginning, then there is no need to traverse. So only in O1 operation, asymptotically we have written time complexity of both of the operations. Here it is taking On and here it is taking O1. So this is the requirement of a stack. We have to apply stack operations like push and pop. Here we are saying insert and delete, both are same. So it should take minimum time O1 for each operation. Now come to the implementation part. Initialization of top, in which we have already discussed how to define a structure. So we are going to define the node. Here this is the keyword struct node is the body of structure. Here we are taking heterogeneous data, which is called integer data, means one part will store the data of integer type. At second part is the variable type of struct node. Pointer link is a pointer variable which will hold the address of the next node. So I am indicating it by using the arrow sign. Now come to the initialization part. Struct node pointer top is equal to null. It means in starting the linked list is empty, top is having the address null. It means it is not having any node address. Now come to the push operation. Push an item onto the stack, onto the top of the stack, which is also called insertion an item. Here is the code. Void push int x. Struct node pointer temp is equal to struct node pointer malloc size of struct node pointer. We have already discussed this line. This line is used to allocate the memory for this node. The size is calculated by size of function. This function is returning the memory of this particular size. So suppose this is the structure of our node. Suppose the address of that node is 100 and it has two parts, one for data, one for address. So it will return, the malloc function will return this address. So we need to hold this address, we need a pointer variable. So I am taking pointer temp. So this variable will hold the address of this memory which is recently allocated by the malloc function. Now our responsibility is to assign the data and to assign the address of the next node. So this line temp arrow data is equal to next. So temp arrow data is equal to x means we are initializing the value. Suppose I am initializing 5 here, and temp arrow link is equal to top. In starting top is equal to null. So I am initializing top is null. So when I am initializing temp arrow link is equal to top means I am assigning null in the next address of the node, and top is equal to temp means now I am assigning temp is my newly created node. The address of temp is assigned to the top, which is the start. So now first node is created, or you can say one element, that is 5, is pushed on the stack. Now take one more example. Now same code is executed, but the new value, that is 23, is to be pushed onto the stack. So now memory allocation is same. I'm again assigning some memory, and suppose this node is having address 200. Now temp data is equal to x, which is 23, and temp arrow link is top. Now there is a change. In the starting, top was having null address, and after inserting the first node, it is having the address 100. Now if I am assigning the 100 address to the temp arrow link means newly node, that is the newly node will hold the address of first node. So now you can see this was the first node. Now it is coming on second position, and address of that node is held by newly created node. Now the question arises, who is holding the address of this second node? Now we are assigning the address of this temporary node, or you can say newly created node, to the top, which is the start, or you can say this is the top of the stack. It means every time, every push operation changing the address held by top. So top will indicating only to the top of the stack. This operation takes only O1 time. Now come to pop operation change. Struct node pointer temp. This is pointer variable. If top is equal to null, then return do nothing, because list is empty. It means pop operation cannot be applied. Temp is equal to top. Now this temporary variable, which is a pointer type, we are assigning top. Top is having the address of first node, so this will control the first node. This is now temp. Now top is equal to temp arrow link. Top is equal to temp. Temp is this, and temp arrow link is the address of second node, which is 100. So now I'm assigning the 100 to directly to the top. It means now my top is linked with the second node. Now I can easily free the first node, which is temp. Now you can see this node is removed, and after pop operation, linked list is as follows. Now you can implement by yourself. Write a program in C to implement stack linked list. Illustrate the following operations on stack, which was implemented by the singly linked list. Push, pop, search. Any question you can write in the comment box. Now implementation part. The same code I have written in code block. So now this is the structure. You can see same data I am taking, integer type data, struct node pointer link. This is the initialization of top. In starting, I am assigning top is equal to null. This is my push operation. Same code I have written in the push operation. Struct node pointer temp is equal to struct node pointer malloc size of struct node, and temp is equal to temp data is equal to x, temp link is equal to top, and top is equal to temp, which I have discussed in the slides. Now come to the pop operation. In pop operation, if I am taking the temporary variable pointer temp, and if top is equal to null, then return, or you can just write some just like this error, sorry, the stack is empty, like this. Now come to this part. Temp is equal to top, top is equal to temp arrow link, and the free temp. Display I have already discussed in the singly linked list. This is the main part. In main part, I'm just writing code to call these function push and second function, that is pop. So rest of the things are very simple, which I have already discussed in previous codes. So I'm not going into the detail of these codes. Just if you are having some problems in these type of codes, scanf, printf, f-flush, std, then you can just watch my previous videos and go into the detail. So now I have to compile this program. Okay, now compile this program. After compilation, there is no error. Now we are executing this code. So enter the data value to push onto the stack. Suppose I am taking 1000. Okay, this value is pushed. You want to another element? Yes, I want to push 2000. Now this 2000 is pushed. Yes, one more operation. 3000 is pushed. Every new value is coming on the top, and one more operation. Push again. Suppose 4000. This is also pushed. Now I don't want to continue. Are you sure to pop an element from the stack? Yes, I'm sure. My element is popped from the stack. One more pop operation. Yes. Are you sure? Yes. So I'm taking twice verification because this is deletion. After deletion, we cannot retrieve the data. That's why we are asking to the user again and again. Yes. One more pop operation. Are you sure? Yes. Now this is the last element. If you wish to pop that element, you can just try for yes. Yes. This is pop. Now suppose anyone apply for pop. Now in this time, you can say the linked list is empty. So what will happen? See it. Sorry, stack is empty. So now this topic is completed. If you have any query, you can ask in the comment box. Thank you. Best of luck.